Today we're talking to Alex George about Kubernetes, what it is, when to use it, why to use it, how to best get started, and about the architecture for his own program called Zeus that he's been recently building out. As you'll hear, Alex spent the last few years at Coinbase, where he got to witness many of the challenges that inspired him to build out Zeus. If any of what we're talking about today sounds interesting to you, or if you'd like to get started with Kubernetes or to try out Zeus, definitely reach out to him. I'm going to add his email below. Let's get started. Whenever I interview people like practitioners in the MLOps space, and I ask them like how they think about choosing tools, it's pretty clear if they don't know Kubernetes or they don't have Kubernetes expertise in house, just forget about it, right? Like, don't even get started with that. And so it feels like there's just like so many tools, it's just like a thriving ecosystem that they're just kind of like leaving on the table. And perhaps for good reason, right? Perhaps like the learning curve is too high. I myself haven't had much experience with Kubernetes, but what you're building seems to be addressing that problem at the core. So, what are you working on?
Yeah. I think like a lot of the initial like hesitation around Kubernetes would be like if you had to set up Kubernetes from scratch, then yeah, it's like a huge headache, and like I can definitely understand that. But like especially within the last like several years, there's a managed Kubernetes like that every major cloud provider has, and even a decent amount of like bare metal or like like specialized cloud providers have managed Kubernetes. So like you don't have to, and it's basically like free. Like they don't like really even charge anything. They can like if you, for example, are using like DigitalOcean, like adding additional nodes to your like Kubernetes pool costs just as much as like just getting a droplet, which is like their version of EC2. Um, so like yeah, I think that maybe like when I talk to people like the first thing that I try to understand is like, well, what do they even know? Do they immediately hear it's complex and then just immediately put on the blinders and then just be like, okay, I will never revisit that ever.
Yeah, yeah,
I
yeah.
think like the better way that I think like I've never really had anybody that has answered that question that's like, I don't want to use Kubernetes because of this specific thing, and they showed that like they've actually like have an understanding of it landscape.
Mm.
So like maybe that's just kind of like, the I don't know if you've ever read Thinking Fast and Slow, but like people like will get this like, impression and then they'll just like use that to like filter everything out instead of, stepping back and being like, well, why exactly do I not want to use this? Or like what would be the benefits of using something like this?
Yeah, yeah. Are there, how do you even know if you have a problem that Kubernetes would be a good solution for?
So like, one of the things that Kubernetes makes like very easy is like let's say you have more than like just one server, right? And you have like, three or four, and most of the time you would want at least like a few different servers to have like a backup. So if like one of them crashes or whatever, like with Kubernetes, the way that it takes like Docker containers, it's able to like just reschedule them onto like the appropriate machines. So like, that already solves a lot of like headaches like right off the bat. Like, what would be the uh, alternative to that? Be like, oh, something is not working on this machine. Let's go like spin up another machine, figure out how to install whatever we need to install, then like run this on this specific machine, and like that obviously doesn't scale.
Yeah.
So like that's like one of the benefits, and like it also has like a very good benefit if you have like a lot of microservices or even just a couple. Like by
Mm.
default, like all the machines on your like Kubernetes cluster can all communicate with each other. You can you can set security settings to like change that. But instead of you having to figure out, oh, how do I set up like networking and like the communication between these servers, like you don't have to do that anymore. It really makes like you know designing stuff on the cloud just so much easier. As assuming like you're like, okay, we don't have to manage the actual install or like whatever of the underlying Kubernetes. Just using it after the fact is actually very easy, actually.
Hmm. Interesting. Okay, so before we get into the idea that you're building now, what has been your background? How did you get into working with Kubernetes in the first place?
Yeah, so like the last place I was working at was at Coinbase Cloud, and at Coinbase Cloud, all the infrastructure is built on Kubernetes. So that was like the last place. And when I was building stuff over there, I was leading their crypto projects for like Ethereum staking, Polygon staking, and then for MEV boost integration for the Ethereum staking projects, and yeah, like seeing how like Kubernetes is definitely like a very good choice for that, but it
Mm.
wasn't like really designed to handle the cases that show up frequently, like in Web3 specific infrastructure, because like most like blockchains have like a few different like patterns. They're like syncing blockchain data, so that's like this constant data like stream coming in. And it's obviously very important. If you stop like being able to sync, then you're not really able to use the blockchain. So it's like managing that, which is kind of like handled by stateful sets, and then just managing like they also need to speak to the outside world. So
Mm.
like things like peer-to-peer like networking setups, which typically if you were running just a regular like web company like Shopify, you would not be exposing ports to the outside world, but you like need that, otherwise you can't like communicate to those systems. And they're very very high like DevOps like maintenance.
Mm.
A lot of the software for like Web3 infrastructure is sort of like in like a beta stage, honestly. So like there would be things would just crash, or especially with the less developed or like the newer like protocol stuff. And like it would cause like one of the things that all engineers hate is like getting woken up at like 2 in the morning.
Yeah,
Um,
yeah.
yeah, so it's like, but if it didn't have Kubernetes, it would be like 10 times worse than like the current like status quo.
Yeah, but even with that, there's still like this overhead of maintenance. And okay, so how much background should people have in order to understand Zeus, the platform that you're building for Kubernetes? Like, could you walk us through maybe like a 5-10 minute kind of intro, or however long it takes to just kind of like establish the main concepts here?
Yeah, so a really good analogy to like what Kubernetes does is very similar to like what a manager would do at like a tech company. So like let's say you have a bunch of different like work that you need to get done. So you hire like workers to like accomplish that goal. You'd have some workers that are very really good at like a specific type of like math, and other ones that are really good at like analysis of that math or data. So they all have their like specific needs. Uh, and if like one of them like calls out sick, like one of your servers goes offline, then your manager can
Mm.
reschedule that work to somebody else. Let's say your workload goes up a lot and you need more workers. Kubernetes can then scale up and basically hire more workers. And
Yeah,
let's
yeah.
say you're in a downturn, things aren't going so well. So like then it can scale down. So it's kind of just
And
like
fire
how we
people.
got we gotta, yeah, we're going through tough times. We gotta lay off a couple of our workers, but you know thankfully they're not people, they're just servers. So
Yeah. No
it
severance
gets
pay.
yeah, there's no severance pay, but so that's like one of the benefits that you get right off the bat.
Got it. And but
One of
how
the
would yeah, 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 go ahead.
And one of the other benefits as well is like, if you use like Kubernetes, like, setting up cloud infrastructure is like, enough of like a headache. But if you wanted to use, and this is like very common with a lot of like companies, especially bigger companies, everyone is setting up like, not just like one region, not just one cloud provider. So multiple regions like AWS, GCP, maybe Azure, maybe something else as well. And if you had to set up all of the work to get your cloud infrastructure working for that same app, like for each of those cloud providers without something like Kubernetes, then you would have like an enormous amount of work to do, because they all have their like intricacies, special like language stuff like cloud formation and things like that on AWS. But
Mm.
if you have like Kubernetes, you can just take the Kubernetes configuration and then just send that to your Kubernetes like cluster pool, and it does the exact same thing. So it kind of like makes the cloud a sort of like universal like layer that you can just have a way to describe your workload, and then Kubernetes can manage the rest.
Yeah. Now, if we were to look over somebody's shoulder as they're setting up this infrastructure, let's say they're using AWS as their cloud provider, what does it look like? They have a repo, and in that repo, they are defining kind of like the goal, the purpose of that manager's kind of role, and then they're specifying the kinds of workers that the manager needs to work in some sort of file, and then there's like a Git actions type of thing. Like, what is actually, yeah? How do they communicate to the Kubernetes world?
Yeah, I can share my screen, and then I can uh,
Yeah, please.
pull up that system diagram, and then I can pull up GitHub and show you some like actual configurations.
Nice.
So I
Yeah.
guess it would be the screen one, right? Not presentation.
Uh, yeah, I think screen. Yeah.
Okay. So like these are the most common workload types in Kubernetes. Like the first one, config map, that is like imagine your like information related to your startup. So it's like okay, we want to start like Postgres and like this sort of like uh, you know whatever stuff that you want to have like tweaked, like okay, we want to change the amount of like buffer memory or whatever. Like that's basically like information related to like your app that you're starting up. Service is what really defines like your interface between yourself, your pods, which are like a that's how like Kubernetes like has its workloads like running. You'll see like pods, which will like be something that is spawned from like a stateful set or a deployment. And a service is kind of like all the ports that you have. So like imagine your container has like port 9000 or whatever, and then you might have another container with like port like 888 or something like that. Your service is kind of like okay, so somebody sends a request to like your pods, like what port does it need to like communicate on. um, Stateful set and deployment, that's kind of like the distinction between the two is like stateful set like data is something that has like data that you really don't want to lose, you want to keep it. So that would
Mm.
be like okay, if you were gonna like deploy like a Postgres database, that like data is not something you want to lose, right? So you would definitely use a stateful set. Deployments are like what you typically would use for like either a like stateless app or like an app that has some state, but it's okay if it doesn't keep that state if it like like it gets like um, restarted or something like that or whatever. But that's kind of like the big distinction between the two.
Yeah.
And inside of those like service files, you'll define stuff like okay, which container is going to like be running for this workload, and then you'll define stuff like well, how many what like resources does this container need? Does it need like 8 CPUs, or like does it need like 16 gigabytes of RAM? And if it's a stateful set, you'll define like okay, what kind of like storage do I need for this? Do I need like 100 like gigabytes? Do I need a terabyte? Um, and yeah, so that's kind of like how you describe the real like application. It really lives in these two files. Um,
Do
and
you have an
then
example of that? Like, can we see that?
yeah, let me take you to
And then is it normally like do you have a different file per service?
so it varies like however like big your application is. So
Mm.
like you could have like multiple like config maps in a single like namespace. So like to explain what a namespace is, that's kind of like imagine it's like a folder, right? And you have like your giant like context or your Kubernetes cluster, and like let's say a region you have set up has like let's say like 25 different namespaces. Each of those namespaces is kind of like a folder, and inside that folder then you'll have a bunch of these files that are like running your like application, whether that's you could have a stateful set in there, a deployment, you could have both. You could have a bunch of config maps, like it's really up to like whatever needs to be in that namespace. And namespace is kind of just like a way for you to like organize your apps, and then if you wanted to find additional stuff, like you could set up like different rules, like this namespace can't communicate with these namespaces. So like it kind of gives you a unit of organization. And yeah,
Yeah, I
and
can
then like
imagine. Let's say like you might have just like pretty common service names, right? Like, and so like pretty common stateful sets too. Like you have like a user's database or something like that, but you want to be able to isolate it from other uh, like departments in your organization or even other aspects of the app. So that's where the namespace comes in to sort of like privatize the space.
exactly. So like if you deployed like a stateful set, and let's say your stateful set's name was just Postgres, like if you deployed that same stateful set into that same namespace again, it would just overwrite whatever was there originally. But if you
Yeah.
deployed it into a new namespace, then it would spin up a new application. So that's like also one of the reasons that you would have like different namespaces. So this is the configuration for like an AVAX node. So like AVAX is a blockchain, and this is like how you would set it up on Kubernetes.
Hmm.
So this is the stateful set. So this is what like really defines like the core workload. This is like how many replicas do you want? So imagine like your pods are like what would be the replica count, and each pod would have a copy of all of these like containers or whatever is defined in the stateful set. So with a replica count of one, it'll spin up one of these. One of the things that you need to do to link these stateful sets to the other infrastructure I showed you is you'll use labels. So like labels will then like tell the Kubernetes like server this application with Zeus AVAX client is related to your service called Zeus AVAX client, and then it will like figure out, okay, so I should associate those ports with the containers that exist on the stateful set.
Hmm. Yeah, got it. And what about, can you just articulate the distinction between a pod and either an image or a container?
Yeah, so like a pod is kind of like what will usually contain either just one container, or like the best practice is like if you have to include like another container that is running in that pod, that it's like a support, file or a
Hmm.
support like container. And the pods are supposed to be, these units of like, division of your work into breaking them into as many pieces that like, or so they have like a commonly defined like role. So like that helps with like scalability and scheduling. So like let's say, this app had two pieces to it but you could definitely split, but let's say this app had two pieces, you could, split into their own like stateful sets each. So like if you were to not do that, that would mean that if half of your app starts to break, then all of your app is broken all of a sudden.
Sure.
But if you have it split into two, if one piece of your app is broken, then you can just like reschedule that or like replace it. And it also like helps with like like if you, for example, had two of these apps that needed to work together, and one of them, required like 8 GB of RAM, and one of them required like 20, and that made it really difficult to like schedule because now you would need a machine that has that entire workload versus like just being able to split it onto a smaller one.
Yeah.
Or and other servers might have like other applications working on them as well. So like the more you can split things up, it really helps with like reliability and robustness.
Cool, cool, cool. Okay, so now a service encapsulates potentially multiple pods, right?
Yeah, so yeah, exactly. But like what's the most common and like the usually, what you'll see people do is that if they have like a stateful set, the most common pattern is you'll see like a single container that runs like that stateful set. Or in the case of like, if they have a support application, then you'll see like two. So this is a support application. So this
Hmm.
allows you to do like, debugging or things on the fly that exist, but it really doesn't have any purpose unless it has something like this. So that's why you'll see like a case like this where it'll have two containers, and this is the real like application. So this is getting the Docker image that has the AVAX like image to pull, and yeah, and then this links to the config map, and so the config map, which I'll show you after this, has like the startup commands that I'm just using as like the arguments in here. And yeah, these are all the ports that are defined. And when I show you the service file, you'll see that these are all linked. So this is how it's like, okay, I need to go to this stateful set. It has these container ports. These are the names of them. And then it kind of like figures out the networking for you.
Yeah, and then where do the images pull from? So can I just like add them into whatever registry and then give some keys to that registry?
Yeah, so like if you have like a public Docker repo, like just like docker.com and go to their Docker hub and you just list the image, then that's good enough. If you have a Docker image though that's in a repo that requires authentication, like let's say you have your repo on AWS or whatever, um, or like a private Docker like repo, then you would have to set up like the authentication for that.
Yeah.
But if it's just a regular like Docker like public repo, you can just put it right here and you know go like right away.
Okay. Okay, cool. So next, okay, so we covered stateful set. Next is the config map.
Yeah. So this has like the startup commands, and the one that like I have referenced in here is this is like the testnet version to start it, and this is like the mainnet version.
Hmm.
And so like just by switching out like the startup commands, I can define like which app do I want to like run. Instead of having, I chose to do it this way instead of like um, like creating an entire duplicate of this and then saying, oh, this is the testnet version, when the only thing you need to change is literally just one line. So,
Yeah.
yeah, it's just kind of like a way that you can compact your workload. Um, and yeah, these other things in here were just kind of like, for like either debugging or like other purposes. Like let's say I wanted to download the blockchain like snapshot that I had. So like let's say I had it up in like S3 already, and I didn't want to like sync from like scratch using the peer-to-peer network. Then I have this like additional
Mm.
helper, and this here would be like for debugging. So if I just change the start command to this, then it would still load up the pod, but then the pod would not like start the application. So then I can like shell in and like
Oh yeah.
see or inspect things.
So and where did you type in? Okay, oh, it might be at the service level. Okay, so now let's dig into service.
Yeah, so this has all of the ports that were defined in that stateful set. So like if you were remembering that there was this peer-to-peer one, this
Mm-hmm.
API one, and a metrics one, and the only one that wasn't defined in there is this specific one, which is used for the ingress. So like for Nginx, there's they use port 80 that you can then reference, and then I'm just like linking port 80 to the HTTPI, um, and then that allows me to expose that port, via an API that you can access with like HTTPS, sort of like authenticated link. Um, yeah. So so the way that the app is able to recognize that this service is mapped to the stateful set is with the labels and the selector, and yeah, and then if you remember me showing you on the stateful set, there was that link on there, and then that's
Mm.
all you really have to do.
But so, okay, so can you go back to the client YAML? Yeah, to the
Yeah,
config. Yeah.
to the stateful set.
No, to the config map.
Oh, okay.
Yeah. Okay, so you see, let's say line 6 start.sh. Where did you ever? I didn't see where you specified this. The
Yeah,
intro.
so like the way that let me show you on here. Here we go.
Got it. Okay. Cool. It's inside the stateful set.
Yeah, so in the stateful set for like the container section, this is here to get like the container that you need. This is defining like if you want to always pull the image. So like let's say you're like developing something and you're gonna that you're gonna make a lot of changes, then you would just set this to like always, and then you can just restart the pods, and then it'll just pull down whatever like changes from your Docker image that you're pulling or
Hmm.
that they're pushing up while you're developing something. But if you don't need that, then you can just do if not present, and then it will only pull it if the image is not on the node that you're running.
But I'm still trying to understand. If you go back to your Miro page, to your Miro board, I don't know if you could pull it up. Oh yeah. So here
Yeah,
we had a distinction between the stateful set and the service.
yeah,
And in what you just showed me in the repo, well, we have that distinction. The config map seems to only be pointing to the stateful is only being used by the stateful set. At what point was the config map being used by the service? Can I see that again?
yeah. So the service it is not using the config map, so the config map is only being used by the stateful set.
Just in this example or in general?
Like yeah, in general, like uh, usually the stateful or the service file is usually pretty like lightweight and simple. It's really just defining like what ports for the most part,
Mm.
and yeah, so the the config map is really almost always related to the application that you're running.
But so much of the application can be non-stateful set-ish, right? Like I can have all these like serverless pods that, sorry, stateless pods that don't need to maintain any memory in between restarts, right? So then they wouldn't be defined in the stateful set.
Yeah, so this is a stateful application. So this one
Yeah.
has so they have this thing called like a PVC, which provisions like SSD or whatever type of uh, disk that you have like set up in your Kubernetes cluster, and then it'll request it and then hold it for you. So
Mm.
this will then find like 2 terabytes of data from your cloud provider, and then it
Mm.
will uniquely link that to your stateful set so that nobody else can use it, and that if your stateful set is restarted or like if you do a lot of things to your stateful set, that it will remain until
Yeah.
you like clean it up.
But for stateless pods, where would those be defined?
So if you had a stateless pod, is that what you said?
Yeah.
Yeah. So if you had a stateless pod, you wouldn't use this. Like this this
Yeah.
is specific for stateful sets that have
Y-
stateful data like this.
what would be the file? What would be the YAML file called normally
Uh,
for defining that?
for this,
No, let's say you now have let's say in your application you have both stateful pods and stateless ones. Right?
gotcha.
Let's say the stateful one would be just for like maintaining like your Postgres or whatever, but there's a bunch of workers doing a bunch of different things that are all stateless. Right? Like it's okay if they have to restart and they don't have to remember anything.
Yeah. So this is a copy of what a deployment would look like. So the deployments are actually like they're very much like the stateful set. There's a lot of like overlaps,
Mm.
but since they don't have that stateful amount of data that you define in those PVCs, that
Yeah.
it's kind of like usually a simpler configuration than your stateful one.
Cool. And I see here you're also referencing those entry points, let's say like line 28 that you've
Yeah.
defined in your config. Okay, cool. Nice. Okay, I got this. So now how do so let's imagine that I've created this. I have this, locally I've, in my repo. Now I'm pushing this up to GitHub. How does this actually propagate to the cloud?
Yeah. So I can show you live. Give me 1 second. So like there's a few different ways that people can do it, but the way that my platform does it is that it uses the temporal it uses temporal to send the request to the Kubernetes API directly. So like one of the things that people will use to gain access to your Kubernetes clusters would be like a kubeconfig. So like just imagine it's kind of just like your authentication file, and if you have that file like on your local computer, for example, then you can like interact with Kubernetes like namespaces and clusters like using the command line. With this platform though, it allows you to do a couple things. Like one is like you can review the configurations that you have just set. It will pre-filter out like what servers aren't relevant or which servers are relevant to your
Mm,
application. So like this one is very lightweight because it's a demo application. It only needs like bare minimum sort of
mm,
memory and CPU. And this one doesn't have the SSD stuff that you would have with like a stateful application. So it's pretty
yeah.
simple. So like yeah, so like through this platform you can just see this as like okay, this is reminding me like what I have like for resource requirements that are defined in my config, and this is the monthly cost that I should expect for this app. And like when you press deploy here, it will then send a request through like the Kubernetes API, but it's also being passed through like temporal because you would really want like something to handle like there's many different things that can go wrong. Like if you send a request for example to AWS, let's say I didn't have like or like AWS didn't give me enough like capacity for deploying like these T3s. So like one thing that could happen would be it would just get stuck. Another thing could happen where it'd be like the Kubernetes API is being overloaded, so like
Mm.
one of the calls gets dropped, and you don't want your application to like deploy part of the application. You either want like all of it or like none of it. So by putting it through like temporal, it gives you this like built-in like way to have like retry logic around all of those operations, so that way things get deployed like very reliably.
For people who don't know about temporal, can you like summarize what they do in like a few
Yeah.
sentences? Yeah.
So like temporal slash like cadence. Cadence is the original name that an application that Uber developed. So Uber created that to solve the issue of chaining a lot of like business flows or like things that are a lot of pieces of a distributed system reliably and stitching them together. So like to illustrate like why that's needed, like we can kind of like walk through like what goes into getting a DoorDash order. So like one, you like open your phone and you click it through like the menus and stuff, and you're like, okay, I found a restaurant. You press like, okay, I'm gonna order this. What it needs to do is like notify the restaurant, notify and find a driver. That driver then needs to go to the restaurant whenever it like makes sense. The driver then like gets in the car like and then gets back and then goes to find the like user's like address to like drop off their stuff. The user gets the stuff, and then they need to like bill the user. They need to then pay the driver, and those are a lot of different steps. And if that whole chain of stuff just did not work, just almost always, they wouldn't have a scalable business. Like if you have like millions of DoorDash orders, and even like 1% of them were like not working, and you needed an engineer to figure it out, they wouldn't have a business very quickly.
Hmm.
So yes.
So then temporal makes sure that it's done sort of transactionally, or that there's if something fails, it keeps trying until it no longer fails. Like what's the logic there?
Yeah, so it's kind of like allows you to build control loops into like systems. So like at one level, like Kubernetes very much is a control loop inside of its own cluster, but temporal allows you to like make anything into like a system that is like control looped. So like the control loop for like this sort of platform is like, okay, I want to be able to deploy stuff, but if something doesn't work, I want it to still continue trying, or like I can define like what I want the loop to then continue to do. So I could like set rules where it's like I wanted to continue trying for an hour, and if it doesn't work after an hour, then I want to notify somebody, or I want to roll back all the things that I tried. So it allows you to define like how do I want to move forward, and then like close the loop on like okay, now if I want to destroy this or clean it up or notify people. So like if something gets stuck in a certain area, it'll only get stuck there, and it'll be you can like check it out on your observability. You can be like this isn't working. It's like in process, so we don't have to like stop or like figure out where things stopped. It's already there and it's already retrying, and then you can resolve the problem there and then update
Hmm.
your like logic if you need to. And control loops are very powerful because they just keep things like moving. If things are stopped, then usually your business is stopped, really. So yeah, it's really just a control loop for distributed systems.
Okay, cool. So this is what you're using to build Zeus, right? So you're building Zeus on top of temporal. Now, in the typical case, like for people who are not using Zeus, how do they figure it out? So let's say they're committing a particular the latest version of their code that already includes all of like the Kubernetes files. Then what? There's a separate service always that picks it up. Is it like a GitHub Actions or like a CI/CD type of thing that then makes a call to the Kubernetes API to update the state?
Yeah, so like a very popular way that people will deploy apps is using Helm charts. So like that is one way, and I'll show you what the Helm chart looks like for like temporal. And so like that's like one thing. So you have a Helm chart and like on the command line with your terminal, you can say, okay, Helm install this Helm chart. But the thing about like the way that Helm charts are set up is that they usually look like this. And this is like very confusing.
Hmm.
Like, okay, web deployment, and okay, it's got like 3,000 conditionals. So you're like, well, which parts of this do I need, or which parts like have like hidden requirements that aren't really transparent? So
Yeah.
like the first step for if you just want to deploy temporal yourself through like Kubernetes is like okay, figure out all of these conditionals that they all map back down to this. So then you have like hundreds like of lines. I think this has close to like 500 lines that then you have to go like figure out okay, how does this map to those conditionals? It's not
Hmm.
very readable in its current stage. Um, and like this also has like hidden kind of like dependencies. It assumes that you've already got the infrastructure to run this. It doesn't tell you what you need like very explicitly. You kind of have to figure it out.
Hmm.
And then in the case of like many different like apps nowadays, that they're not just like a single like standalone app. A lot of apps have like dependencies on needing like a database or like a different like technology to use like temporals like Helm chart. You would like either want like a data store of like MySQL, Postgres, or Cassandra. And then you would use something like Elasticsearch for like their observability, and then they have these other two things set up. So that would assume that you already got like that figured out, and then you would then go to like your cluster and like the command line and then run something like this, and then you would just hope that it installs.
Yeah, but can you? Maybe we need to take like one step back and just kind of like, can you paint a picture of the kind of workflow that might fail? So, because what I have in mind is, let's imagine we already have like a Kubernetes cluster running, right? And we have a bunch of
Yeah.
different services. But really the only change that now I need to introduce is, let's say, to increase the memory that I allot to one of my stateful set services or something, right? Like to one of my stateful set pods. So then I go, I do that change locally in my IDE. Then I commit it to GitHub. What would be the transaction that could possibly fail that would necessitate like this sort of conditional logic?
Yeah, so like if you wanted to, let's say you've already got this Helm chart deployed, assuming that the Helm chart already had like a value for like setting a resource. So let me try to see if there's one in here. Okay, so like let's say like the heap size or
Mm,
whatever, or something
yeah.
you changed here. I'm trying to find something, that looks like this. Okay, here they actually have resources here. So like let's say you're like, okay, we need more memory for our application. Instead of this, we're gonna add, 1 GB. If you then like changed it here, then committed it or whatever, and then reinstalled it, it would then like apply those changes to your like existing deployed cluster.
Mm-hmm.
And let's say one of the things that could happen would be like it's not schedulable, which means like you wanted 1 GB, but we don't have any capacity on any machines to make that work. So then it will just
Mm,
be stuck. It'll just say, well, we can't schedule, and then you would have to figure that out, usually from like your observability, or like you would watch it from like the install, and you would see that it's not working.
very cool. Okay, that makes a lot of sense. All right, nice. So these are some of the challenges. What are some other challenges that sort of like motivated you to create Zeus?
So like this whole process of like managing these Helm charts isn't like very scalable, and it doesn't really allow you to like reuse stuff. Like let's say you just wanted like one of these pieces or a couple of these pieces from like this temporal Helm chart. It's not very easy to like break it up, and it's also not very easy to understand like what parts of this I need to configure from the infrastructure side. What servers should I be running, and which servers on like which platform, like meaning like AWS or GCP. The whole like process of like these Helm charts. Also, it's like if if you have like a Helm chart, right, and you're deploying something like once, and you only have to manage like one application, that's like it's not too bad. But like let's say you have a case like at Coinbase where it's like a Helm chart could represent like an Ethereum beacon or something, and now you're deploying hundreds of them. Like how efficient is the process of, okay, let me update this, and then like send out an upgrade command, which was largely done by opening the terminal and like upgrading them like by hand and hundreds of
Mm,
times.
mm.
And that process is like not very fun.
Yeah, for sure.
Honestly. uh, like one of the ways that people have like come up with to try to make the process of deploying stuff a lot better is like this idea of GitOps. So like GitOps is kind of like sort of this like you were like talking back about like the committing it on Git and then pushing it up. It will then like read whatever changes on like your Helm chart, and then it will like attempt to like deploy whatever that was to like wherever you told it to. um, but like the kind of issue with like using Git and like GitOps is like, one, it doesn't really handle like anything other than like the most like basic kind of like conditions. Meaning like if you try to like apply it, right, or like if you were going to send out GitOps to try to roll out like hundreds of like upgrades, it doesn't have the smarts to figure out or how to like resolve something. It will just like get stuck, and then you have to like figure that out. And like the way that it like manages like their own like control loop for like GitOps is you have to like install like a GitOps operator in your Kubernetes cluster,
Mm.
and that like process is like it's not easy, and it's like
Yeah,
per cloud provider they have their own like specific things that are very hard to figure out. Like Azure has their own thing, AWS, and it's like now you have this like difficult like installation process, and
sure.
it's also not very well like built for like deploying like hundreds of like changes at once. And then like you're very much reliant on like Git for everything. And if you have a decent amount of like engineers, especially at like larger companies, like you're going to run into cases where there's going to be a lot of Git merging that's happening, and having to manage like a dynamic system like that, especially one that like will frequently get stuck, which when I was using GitOps, it definitely would. Like there would just be lots of things that would just like not work for whatever reason, and then the
Mm.
operator would get stuck. Now you're just like back into like this process of spinning your wheels again.
Okay, got it. So we're still in the deployment category and kind of
Yeah.
like the challenges inherent there. Is that the main motivation for creating Zeus? Is it about the deployment?
So, like the deployment is like one aspect of it. The whole like concept of like what Zeus is able to do and why it like exists is that like the whole process of building infrastructure on the cloud makes no sense to me.
Mhm.
And by like for looking at like the way that like GitOps like really breaks at scale, looking at like Terraform. Are you familiar with Terraform? I can explain
Yeah. I'm
that bit
familiar
as
with
well.
Terraform, although I've mostly used Pulumi. But for folks who don't know much about infrastructure as code, can you maybe
Yeah.
walk us through it?
Let me try to find a good repo that shows exactly how bad Terraform can get.
And people might also be familiar with like CloudFormation, right? They come from AWS.
Yeah. So like Terraform is not a real like coding language. It's kind of like a pseudo language, which is already bad enough. Um, and The way that it works is it's not really like they say infrastructure is code, but it's not really code.
Hmm.
Um, and when you define something like this, like module, Windows Server, whatever, you now have to like first of all figure out how to get this from like Terraform and then configure it into this, and then when you like go to apply it, then it like frequently and almost always like runs into issues that are just like, okay, this version isn't supported anymore, like this or whatever. And for most like companies, especially larger companies, they have like hundreds, if not like thousand or thousands of like pages that look like this that are just not like readable. They're not like type safe, and they can't do like things that are dynamic at all. And they have all kinds of weird like version things, and it breaks like a lot, especially with like trying to apply like GitOps to like this, as some people have tried to do. It frequently you'll have lots of engineers like that need to change like infrastructure, and it like frequently always like breaks or it's caught in some kind of locking loop or whatever, where somebody is trying to apply something else, somebody else is trying to apply something, and it gets stuck in this loop. And I can't even tell you how much time like Terraform like wastes. It is just like a nightmare, and I can't believe that it's like what people like use.
But the
um,
goal, can you just like remind us of the goal here though? So like why have a Terraform script?
Yeah, so like what Terraform was like designed to solve is like, figuring out like what your infrastructure is and then like applying it so that you could like read it, and so things were like more transparent. But like to me that doesn't really make any sense. Like because they already track first of all what infrastructure you're using through like billing. How do you think they're like charging you? And also like you can easily do something like this in a database, and then it can solve like the issue of like version compatibility. So like let's say you wanted to get this Windows server, right? And you wanted like version 1.5, but let's say Azure's like, we're going to make a change to this so that version like 1.2 like needs a whole different set of like whatever, it needs different like configurations. So if you have something like an API that is like managing that, you can say, oh, you want the 1.2 version. We've already figured out how to reconfigure that based off of this. We've already solved this problem for you. You can just say 1.2, and then we'll either deduce what we need from that call to make it work, or like it should really then be a breaking change with like a 2.0 instead of like a 1.2. And you don't have to track or write any of this ever.
Are you
So yeah.
objecting to like to the verbosity of this or to the concept of infrastructure as code?
So like it's definitely more of like uh, kind of like a little bit of both. I think that infrastructure as code is definitely not defining what it is. First of all, like Terraform isn't a real language, so it's like it can't do things like for loops, for example. So you can't really abstract away anything. This is literally just the same as if you went to the UI, found this like information, clicked on it, and then like send it to the server. And it's not really code because it really doesn't do anything except these are really just a way to format an API call. Like the way that these are working behind the scenes is that it takes this information and then it sends it to the cloud provider's API to then like provision that resource. So like it doesn't make any sense to like put it in this format. And then it's like it's very difficult to figure out how things are breaking or like how do you put them together. Like if you make a mistake somewhere in here, if you have like something like a typo or something like that, the error responses you get back are usually like cryptic, and it's like trying to figure out how to like code something in something that's not a real language that has a lot of things that are like very brittle. It's very like it's very confusing and very time consuming. Honestly, like designing something like this and then maintaining it is like a nightmare. It Yeah, it's like definitely the bane of many engineers.
I promised the audience that this part of the episode was not brought to you by Pulumi because it sounds like it sounds like an advertisement for Pulumi. Have you ever used them?
I've played around with them, but like I do like the idea of what they're doing is like making it more code like things that like allow you to like not have to split your paradigms and like okay we know how to code in like Go or like Ruby or whatever, like why can't we just use that, like why are we learning this like pseudo language that can't really be tested. Like it's very easy to write a unit test for like okay you're doing this change or whatever and you want to add two servers instead of one. Like if it's in like Go, it's very easy to do that. If it's in this, it's like, okay, you're gonna write a regex, like that would just
Yeah.
just make something that's bad even worse.
I'm trying to see if there's something I can find that is. So this is defining a job in AWS Glue, for example, right? And you could see I'm just like, and this is in TypeScript, but they have I could do it in Python too. And you see here, I'm just like I'm defining, let's say, like a bucket object. This is where I'm going to basically upload some script, and here I just define a new glue job. And like the thing that's pretty nice about this is it being TypeScript. I could just always click into it and understand, well, what are the arguments that I actually need, right? So, okay, got it. This is a job command, so you could just see what the arguments need to be. Okay, got it. Name, Python version, script location. And then it gives you pretty nice error messages along the way, right? So you can define roles, but I think this still gets a little bit. I mean, and here I don't think I have any loops here, but you can have loops, right? You could just like keep uploading various files to S3 or create as many buckets as you wish, or create as many jobs or workflows or whatever. So I think this is still getting a little bit at what you're concerned about, though, which is it feels like this part.
So
These are
like
some of the things. Yeah.
like some of the things that like you can do with like something like Pulumi or like levels of abstraction like what we have is that you can really create like sort of like same patterns that you see in like regular code where it's like imagine you have like a class object or something that you'd see in like object oriented like programming that like let's say your S3 bucket that you've defined here, it could be used with that exact same like config for like three or four different like applications that have either some like close like relation or zero relation. What you can do with like a system with like code is abstract that, be like okay we have these applications, we're just going to call that object that we've defined over there and now it's going to deploy that. Now we don't have to build that again from scratch.
Right.
But like doing something like that in like Terraform is
Yeah.
virtually impossible.
Totally. Totally. Okay. Okay. Back to you.
Yeah, so like what our like platform is kind of like set up to do like at this moment is not to like solve all of like what Pulumi and like Terraform are doing like at this moment. It's more around like all the things that are related to like a Kate's application. So like what you don't have to do when you use a platform like this is like figure out like which of these machine types make sense for my application. This will like figure it out and like pre-filter them, which allows you then to like go from zero to deployed on a cloud in like a minute. Um,
Yeah.
and then there's like hundreds of machine types for each like cloud provider. So that's like one of the like benefits. The other benefit is also being able to quickly see like what is the difference between these cloud providers. So if I have like DigitalOcean
Oh,
or like
cool. Yeah.
Google
Yeah.
Cloud or AWS, I can be like, oh well, it's like it's way more expensive on AWS, and I don't really need a specific AWS technology. Why don't I just use DigitalOcean? That'll work just fine for me. And then
You're
when
more cloud agnostic when you're writing these deployment files, right?
Yeah, so like going back to what I was saying about Kate kind of being this like universal layer for like cloud environments, that's what like this platform is like really like able to do. It's instead of you needing like one cloud provider through a platform like this, you already have access to all of these cloud providers and all their technologies on this like universal like Kate layer, and then it can do stuff like reading in your configs that you have defined, and then figure out like, well, what do you actually need, defined by your actual like configuration that you want to deploy. Um, if you have like resource requirements, these are demo apps, so they don't have any CPU
Sure.
or memory requirements.
But Alex, we've been talking about Kubernetes. Kate
Yeah,
is
Kates is Kubernetes. That's just common shorthand for Kubernetes. Because Kubernetes is too long, it's too many syllables. So Kates, single syllable, is the easy way to say it.
that's when you see the K8S.
Yes.
Is that
Yeah.
yeah? Okay. Uh, can we go back to the system diagram?
Yeah.
Okay. So this is sort of like the world that everybody lives in, right? Like all the stuff on the right.
Yeah.
Now
So
you're building a complete extension to that. So what are you building exactly?
Yeah, so like one of the aspects about this setup around like the configuration that is not really solved well by Helm is like defining stuff in like this sort of like system allows you to easily create derivative applications. So like for example, how I was showing you on that one AVAX node, how the only difference between that application, a testnet and a mainnet, was the startup command, and then there's
Mm,
like maybe resource commands. So through this sort of like platform, um, everything is like defined using like Go, like real Go code. So like there's this concept of this what I call like a config driver, where you can apply like a config driver to like just make the changes needed to create your derivative app. So that would
mm,
mean in this case like mainnet, testnet, um, and like also it allows you to then stack pieces that you need or not. So like for example, like the ingress like creates like that API that's externally accessible HTTPS. Like if you were running your node for like a validate or something, you wouldn't want that. So the only thing that you would need to do differently is just not include that piece of the config, because everything is modular and everything is like stackable. Like it is very high like emphasis on being compatible and only being the like atomic unit as much as possible,
mhm.
versus like when I was showing you that temporal chart, like everything is just bundled in there, and so it's like you have to always entangle it, like from scratch. Like
Yeah.
imagine if like deploying like a cloud application was as simple for everything as like, oh, I just want to deploy that. Like think about how many times people use like a Postgres database or use like any of these like very popular technologies like Kafka or Confluent or streaming, or like the list goes, or like Redis. Why is it so difficult to deploy those applications which are so popular? Why can't you just do that? You go to those Helm charts, they're not readable. You try to
Mm,
deploy them, it doesn't make any sense. Things are broken, and it's like the same problem is solved by every single person that needs to use it from scratch. It's very much like, imagine like you if you were designing like a new piece of software, you couldn't import any libraries from any open source stuff or like whatever. How quickly do you think you'd be able to build those apps?
right. Right.
Yeah, so like the kind of like there's a very high emphasis on that, and then it also doesn't require you to like figure out Terraform whatever. It already figures that out from like the deployments,
Mm,
and then it deploys it for you. And there's no
mm.
dependencies on needing like GitOps operators because it just uses the API, so it's very lightweight. And so after you deploy it though, it goes into like your namespace. So this would be like a
Sorry, the
namespace.
deployment process in this case involves that UI that you just showed us, or does
Yeah,
it
so
also connect to some like GitOps basically? Like, what's the flow?
Yeah, so it doesn't use any GitOps at all. All it does is it like sends a request directly to the Kubernetes like server. So the Kubernetes server has like an endpoint that's called like create deployment, and you
Mm,
just post it or like literally just send like an API request to that with
yeah.
the deployment configuration, and then it does that. So it just does that directly, and it just links that to like your entire workload, and then it just deploys all of them.
And this is done already by your system, or do I need to configure that?
So that is already done by this system.
Okay, so I just need to commit my code, or I need to upload it to the UI.
So like the way that it's set up, it's the way that you can deploy stuff through our platform is either with the we have an API like SDK that you can use, and
Mm,
then so you can programmatically do that. So you could add
yeah,
that to like for example like a CI config or whatever that like on commit, then it like runs through the steps and then deploys it. Um, and it also has like the UI as well. So there's two different ways that you can deploy stuff.
got it. Okay, cool. So now deployment is uh, taken off my plate, and now it's on yours. What do you do with it? So then, okay, so then you convert it, let's say, into like the Terraform. So you have to manage all of that complexity, or yeah, and you do that cloud by cloud, right? So you've had to kind of specify which cloud. Yeah,
Yeah, so I don't have any like Terraform or any of that code that's needed. The way that it works is like each of those like cloud providers has like APIs that define like what machine types they have. All I've
mm,
done is like I've set up like some code that is just able to read that and then figure out the pricing for each of these cloud providers and then just manages the API process. And then that is just one stage in like this greater like temporal like control loop
mm-hmm.
so that you're at this point and you're like I want to deploy this app and I need to spin up a new server for this app, and I know what server I want. So you define that either on like the UI or like through the API call. So what
Yeah,
our platform does is then takes that information and then spins up that machine and then stores like, okay, we created this node type on AWS and we spun it up on like X time or whatever. We keep track of that sort of stuff and you don't have to figure out Terraform or whatever. We always have like the information of like when was this server like online, when did you spin it down, that sort of
cool,
stuff. So the user doesn't have to do any work.
cool, cool. So what's all of the stuff? Oh, this is the internal platform, right?
Yeah. So this is like the internal platform that shows like let's say you're at this stage and you have like one of your configurations that you have that you push through. Like you add this other piece to it, which allows it to route to the right place. So the cloud context namespace is like um, let's say you want to deploy it on AWS, so that would be like in like this header like kind of message. It's like, and then you would say, okay, either we want to deploy it on this existing namespace, or we want to like request a new namespace, and that's like that folder stuff that we were talking about. And
Mm,
then also another piece would be like what region would you want the deployment on,
mm,
and so that is the piece that you add in with the configurations that you have set, and then it takes that information and then it routes it through temporal. So like temporal at this point, if it needs like a new server, then it will like spin up one for like your application. But
sure,
let's say it has the server, then it sends the request, to the Kubernetes API directly, which will then deploy like your workload. So like let's say this was the AVAX node that we were looking at earlier, where it has that stateful set. It would we'd be looking at the namespace and it would spin up that like workload and it would show the pods and then you can interact with the app and that's like really your live app at that point.
yeah, yeah. Those blocks that we're looking at, Hermes, and who is that one underneath there? This
So
is
this
this is
one,
this is just kind of like your internal module. Hestia, these are your internal modules for organizing this.
yeah, exactly. So like internally we need a way to like route messages. And we also have like things around like security and authorization. So like if you have a namespace that you can set whatever kind of like user like level roles on it. If you have like a shared context, like in our case where we have one that's like for like demo purposes, where
Yeah,
you could have a namespace and someone that's unrelated to you can have their own like namespace, but you would not be able to interact with their namespace stuff like through our platform. So it is kind of like that layer that like is this proxy layer that it makes like the whole process of isolating user like control for Kubernetes a lot easier. And it's pretty difficult to do that in its current state without something like this, because then you would have to like manage and like write a lot of like configuration files like role-based access control and stuff and then deploy those like directly onto your Kubernetes like cluster. But since this is a proxy that doesn't allow you direct access to that, and then we can just put it through something like this. Um, and one of the you have a question?
yeah. No, like what? Yeah, sorry. Go ahead. Yeah, finish.
Oh, I was just gonna say, so like there's two different ways that like our platform works. Is like you can deploy stuff through our platform, which is already connected to these cloud providers. But in the cases of like, enterprise users or people with their own sort of requirements on their own infrastructure, they can set up this middleware we have, which allows them to basically get everything that, all the benefits of using this platform, and then it orchestrates it directly onto
Mm.
their like clusters and namespaces and cloud setups.
Oh, very cool. On the left, if you scroll even more to the left,
Yeah.
what do we have? So past the internal, past Olympus.
Yeah, so this is kind of like one of the ways that I've decomposed like a complex app. So, for example, like I created this one to kind of show like, okay, how would you create like an Ethereum staking cluster? So an
Hmm.
Ethereum like staking cluster, it has like two like main components, like a beacon. So it needs to be able to communicate with the blockchain. And the other part is like the validator client. So the validator client is like, okay, you need to be able to assign messages like, for your validator to complete its like validation duties. And like if you are building things in, the traditional way with like Helm chart or whatever, the way that your like development time would like vastly different from this is that because everything here is like stackable, you don't have to rewrite Helm charts, figure out the templating, or like try to figure out how you can add another if conditional to your already unreadable YAML file. And like the way that it works is like, okay, it kind of, and also like one of the things that you would be very easily able to do is like switch out like the client like type, like to kind of like explain that a little bit more. Like so like for an Ethereum beacon, there's like consensus client, and then execution client would be its own sort of like setup. So if you're familiar with stuff like Geth, or if you've ever heard of something like that, that would be like an execution client. And then consensus client could be like Prism, Lighthouse, or there's a few different like options. So like if you wanted to support a different client as well,
Mm.
like that's another thing that you would then have to figure out in a Helm chart. So the way that it's done right now, like if you go to like Ethereum Foundation's like official like Helm charts that they have set up, they have like their own like Helm charts for each of those like configurations, which is like already difficult, and they already look like that stuff that I was showing you from the temporal stuff. So like the way that you would get a different client through this platform is you would use like a config driver. You'd be like, well, we just need to change the startup commands. If they have a few different like port setups, okay, you can just overwrite those and change them with like a go like struct that just overwrites them. And if they have any other things, like if they need more resources or whatever, you can do that with a few lines of code, and you don't have to change anything about your base configuration for like a consensus client. And then the same thing applies to like execution clients. And because they're in these well-defined like modules that clearly define what this workload is supposed to mean, that you can change out whatever client for the consensus client and then stack it with your execution client and always get a working beacon. So like all of a sudden, if you've just designed one beacon with one like client type for each of those, like to get every single client is very very easy. You can do that very like within a few days versus like the way that it would exist now. It's like you would basically never do it because that's basically the reality that exists at like Coinbase Cloud. Like they only support like Lighthouse and Prism, and the only execution client that they support is Geth. They might support one other execution client now, since I've left, but there's like 4 or 5 different options for each of those, and that just goes to show like even a place that is as well capitalized as Coinbase isn't able to do something like that because of looking back at those Helm charts, look at the complexity that existed just to change anything, let alone something like a client. And then there's also like the validator client, which then has like the same client types that could be your consensus client here. Um, and all you have to do to change out all of these pieces is like, okay, you just change out the Docker image that you're pulling in the startup commands. And now I have a staking cluster, so I need this validator client to be in this like overall config. These like merge into like this beacon component. This here is now like, because you're doing staking, you're adding your validator client, and now like you have this package that then can be deployed on any cloud provider like through like this system that we talked about already. And changing all of these apps like is very very easy to do now. So like by creating like one shell for the beacon, and the shell for validator client, you're able to support like the 4 or 5 different like options per client like provider here. And like there's other things that you would want, like an archive version of a beacon node, which is like storing more of the blockchain data. You can easily do that, and all you have to do is build it once. And now you get like 20 different derivative applications that you can build, like maybe a few hours per derivative application. And versus like trying to do that and support that in its current state is so difficult that even places like Coinbase can't do it.
Yeah, and it feels like not just replacing any one of these services or components, but it's just like experimenting with another one, right? Because you don't have to say like reroute from one port to the next. You can just like open another port and like test out another one of these components, right? And just like see how it works without ever kind of like green lighting it into production yet.
Exactly. It's very easy because it's just like, imagine like instead of like infrastructure being in its current state, imagine this was like real code and it's just like you're importing a library that's called consensus client, and you just want to change a few commands that you're using. That is as simple as like this
Yeah.
platform is making it. So yeah, changing a few ports or changing something to experiment and not having to figure out the larger system. You can isolate whatever change to a very small piece, but still be like relatively certain that your greater scheme of this much more complex app is able to work. Allows you to like very quickly iterate and change things.
How do you protect against? So I'm trying to now understand like the workflow that you might have to sort of like design into temporal and all the ways in which different things might fail and all the decisions that you might have to make about ensuring that, well, if parts of the application fail, not every part of the application should fail, or perhaps the entire application should fail. Like there's a lot of decisions there, and it feels like the reason it was complex to begin with is because the user seems to need to be involved in expressing their desires very precisely. And you seem to be abstracting that away in some way. Is there either a risk that users are not given expressive enough language, or not? Like, I guess, like, why did it take so long for somebody to abstract away the underlying complexity?
I think that like my sort of guess on this is that a lot of people that are the infrastructure engineers, people that are like more of like SRE type of like individuals, are usually not like very strong coders, and they're
Hmm.
usually not like experts in SQL. And so like what I've done is like taken a back end coding approach, like strong like principles towards like, okay, you want strongly typed code for something that's very important like deploying a server, and then creating like relational like setups with Postgres. So now I can be like, well, okay, this platform or this like cloud provider, this is related to this like cluster that's getting deployed, and I can map like everything like end to end. But like that sort of skill set is like very rare to have both of those, and
Hmm.
also like be able to like do infrastructure like well in its current state. That I think that's like one of the top reasons, if I had to guess.
Yeah, I can see that. So, at what level of maturity is the product now? Are you looking for users? Are you looking for design partners? How can people be helpful to you?
Yeah, so we do have like somebody that we're chatting to that would be like a good enterprise user, and they seem very interested. And that's in like the Web3 space. And there's a few other like big Web3 sort of like organizations that are interested. But like this platform is like very good at solving like DevOps and designing stuff very quickly, and like something like assembling or assembling and rapidly deassembling and constructing like distributed systems is very easy, which I've seen like there could be a lot of like applications in ML ops. So we're definitely looking for design partners for that. So if like if anybody is listening that is interested, definitely feel free to reach out. Um, and yeah, so we're kind of like in that stage of like trying to find more design partners.
So, how can people get started now? Is this already like generally available?
Yeah, so you could go to like, the cloud.zeus.fy/sign up, and it's open sign up, so anybody on the internet can sign up and use it. And if you can even deploy like a test cluster for free without putting a credit card up, and that'll allow you to deploy any like cluster. You can either deploy your own, or you could use one of these like demo apps, and then you'll see like the full end-to-end stuff. And if you don't have your credit card after like an hour, it'll just delete your app, but it allows you to evaluate and try things out. There's also this UI builder that greatly simplifies like building stuff on Kubernetes. So like, I have a tutorial that I set up on Medium that shows how I was able to create like an API. It's actually this very API that exists here, and I was
Hmm.
able to create it within 5 minutes. And it like takes all the things that were like complex or very confusing, like what labels are important, how do I label things? Because if you get the labels wrong, it doesn't work.
Yeah,
Like
yeah.
setting up like the ingress, it basically takes the things that like the labels solves them for you. If you just define your container ports, like it then solves the service file for you. You just click add and it literally just solves it. And then you click ingress and you're like, well, which port do you want exposed to the ingress? And it's all like UI based. I don't think there's an easier way to get started with Kubernetes, so they can give that a shot.
For people who are still scared of getting into Kubernetes, can you give us some words of encouragement or motivation? Like, is it worth doing it? And if so, for what kind of people is it worth doing it?
I would say like if you have any sort of like, relationship with the cloud, or like, let's say you're a researcher or whatever, I don't think that, not getting, good at Kubernetes would like it would kind of like hold you back from like being able to do like state of the art sort of stuff. So like if you're like, maybe more of like a hobbyist and you don't, see yourself needing something powerful from the cloud, or, you don't interact with it very much, then, there's no need. But if you like, want to, take part in like what exists now, like it's really mostly done on like Kubernetes. Like, OpenAI builds their stuff on Kubernetes for a reason, and a lot of like enterprises do. And there's a lot of very good open source projects that allow you to take advantage of like some very smart people's work for free. So like, I would highly encourage you to, use it. And that Kubernetes has gotten a lot easier, from my platform and from like other technologies that have, existed. And it's definitely not as intimidating as it was.
Is the best way to get started to read your Medium article, or are there other resources you would send people?
I think so. I think if if you understand like Docker containers, that that's all you really need to be able to use this platform pretty fluently. So yeah, and then I think the Medium articles that I have are very easy for people to be able to pick up. The article I have on this API creation is easy enough for like a middle schooler. so,
Yeah, yeah.
so I think that I don't think there's an easier way, honestly, to get started.
Nice. Where can people find you?
So they can send me an email, and I don't know if you have like something that we can like
I'll
edit
add show
or add.
notes. Yeah, yeah.
Yeah, and I can
At
add
the
in my
bottom.
email that they can send an email, and I can add my Calendly link so they can like schedule some time to chat if they want.
I think it would be fascinating to get somebody who had used this for an MLOps applications, for an MLOps to come and talk about that experience too. Once we push people your way, I think that will be fascinating.
Yeah, and like, going back to the question of like, having custom needs around like the air conditions, like one of the things that like, would exist in like an enterprise level relationship would be, they're much more likely to use the external orchestrator that I have over here, and they can then like allow themselves to either, take on that stuff, or they can ask us to like design it a certain way, or like set a few different of the control loop parameters to like match whatever requirements they have. And that would be kind of like the like enterprise like tailoring sort of approach.
Yeah. Cool. Alex, thank you very much for sharing with us Zeus. This
Yeah,
is
thanks for having
extremely
me.
fascinating.
Appreciate it.